All right, thank you all for joining. We're going to go ahead and get started with a few comments before we turn it over so that Cyrus can give his presentation. We will be using the chat and raise hand features of Zoom, but we do ask that if possible, we wait till the end of the presentation, and then we will help monitor chat and such at that point. We have enabled subtitles and the ability to view a live transcript. If you utilize the CC button at the bottom of the screen, you can view the live transcript or turn on or off the subtitles if you would like. I wanted to note that we are recording this meeting. It is always nice for the presenter to be able to see other people so they don't feel like they're just talking to a box, but we also understand that there are times that people prefer or need to keep their cameras off. So we will also leave that up to you. If you would like to rename yourself or to include your pronouns, please do so. And if you need help with that, you can chat me and I will help you get that set up. And then also would like to just, before we get started, just acknowledge that the University of Colorado's 4 campuses are on the traditional territories and ancestral homelands of the Cheyenne, Arapaho, Ute, Apache, Comanche, Kiowa, Lakota, Pueblo, and Shoshone nations. Further, we acknowledge the 48 contemporary tribal nations historically tied to the lands that comprise what is now called Colorado. Acknowledging that we live in the homelands of Indigenous peoples recognizes the original stewardship of these lands and their legacies. With this land acknowledgement, we celebrate the many contributions of Native peoples and also recognize the sophisticated and intricate knowledge systems Indigenous peoples have developed in relationship to their lands. And with that, I believe Myron is going to do the introduction.
Thank you, Cindy. It's my pleasure to introduce today's speaker, Cyrus Hester, who's giving a talk entitled, "What Can High-Resolution Data Tell Us About Urban-Rural Mortality Disparities Among Coloradans?" Cyrus has been a postdoc at IBS since March of 2020, arriving just days before we all stopped working on campus to work with me, Lori Hunter, and Stefan Lake, among others. So you should find him now that we're trickling back and learn about all the interesting things that he's done in his well-established career and is doing now. Prior to his work here, Cyrus received his PhD in sustainability from Arizona State University in 2019, with a dissertation on the health consequences of environmental issues related to long-term mining in Arizona. And just to tease you about his many other accomplishments, he has also worked as an environmental specialist for the Bad River Band of Lake Superior, Chippewa in Wisconsin. It's quite an accomplishment, quite a different world from being in CU Boulder. I won't take up any more of Cyrus's time. Thanks to him and to all of you for being here. And I look forward to hearing the questions in the talk. Thank you.
Thank you, Myron. With that introduction, I'll get started. If you could hold questions till the end, that would be very helpful. I'll try to address as much as I can during the talk, not afterwards. So we're going to be talking about, as Myron alluded to, scale and its effect on our understanding of the spatial dynamics of mortality in Colorado. We're really focused today on urban and rural dynamics of mortality, with an emphasis on the rural mortality penalty that's been observed to emerge in recent decades. So there's longstanding evidence of persistent effects from education, race, and the environment on longevity. And when we talk about the environment, today we're really focusing on living environment, urban versus rural as a kind of coarse dichotomy of ways to describe that. And since sometime in the 90s, early 2000s, it's been observed that there's an emergence of a rural mortality penalty. This is largely pre-COVID data we're talking about and trends. But you can see on the top right corner from Kosman, in the solid lines for both rural white and Black Americans, the divergence from their urban counterparts featured here in dotted lines, sometime in the latter part of the 20th century, where gains in longevity were lost. The trend started to climb upwards, where mortality rates are climbing amongst rural Americans of various demographic groups, and among different causes, multiple causes of mortality we're also seeing. This separates America from other Western nations. You can see in the bottom right corner the well-known publication by Case and Deaton, where most other Western nations have continued to see progress in declining mortality, and the U.S. is departing and has continued to depart from them over the decades. We see this here in Colorado as well. You can see traumatic mortality rates among younger adults on the left-hand panels from ages 15 to even as high as 45 to 60 tend to be elevated and persistently elevated in rural parts of the state compared to urban areas. And also for some middle-aged adults in cancer rates, though rates have tended to trend down, they remain higher in rural than urban populations. So Colorado is not immune from this trend. One of the challenges for addressing this, this health crisis is that much of the data and research, though well done to date, has relied upon publicly available data aggregated to the county scale. Of course, counties in the western part of the US are very large, which is a challenge in of itself. And there's really been less research at finer scales or emphasizing geographic heterogeneity within such categories as urban and rural places. And in the few kind of noteworthy cases that have looked at scalar effects, there have been some conflicting, we might say, results. In one case by Melliker, cancer clusters could only be identified using individual point data and were not locatable at coarser scales. In contrast, an older study in China found that they could only find cancer clusters detectable at the provincial scale and otherwise appeared random beneath that. In another case where scale was considered in the analysis of the correlation between water quality and gastrointestinal illness, the correlation was seen to increase with scale, and this was viewed as a scalar bias implicit in the study of that relationship. This has some theoretical and practical implications. I should say our inability today to really focus on the relationship between scale and mortality patterns has some implications. One is just the obvious statement that our ability to infer drivers of phenomena is dependent upon the relationship between pattern and process. The processes underlying temporal and spatial patterns is key for identifying the location of phenomenon, hotspots, for instance, but also the drivers. And the fact that scale affects this ability to infer is key. And so there's a classic example from landscape ecology where at a very large regional, say a forest scale, two species might be seen to be positively correlated in space, but viewed at a finer scale, at the local scale, competitive exclusion means that they occupy very different parts of that landscape. One could also think about the relationship between GDP at the national scale and what that says or doesn't say about inequality at finer scales in the distribution of wealth, to give a social example. So there's a well-known challenge of the ecological fallacy where we infer individual or finer scale dynamics from coarse scale data and how that can be misleading. As I gave an example of the ecological example just a minute ago. But it's also true that there are emergent phenomena, group dynamics in complex systems, which include pretty much all social and economic systems. And so there are some factors that we would only expect to emerge and be identifiable at coarser scales of aggregation. And so there's this trade-off, this tension between scales analysis. It's key that we identify the appropriate scales to study these problems with, because that's the only way we can really understand them, but also direct public health interventions and funding to the right places at the right time. So with that being said, the objectives of the research to date and what I'll be covering in this talk is to really evaluate the risk of aggregation and zonation bias in mortality research with a lot of reference to the county scale given its popularity. Zonation bias, I should mention, is a little bit different from scales of aggregation. Zonation bias is really about how we delineate space rather than how coarsely we aggregate it. And I'll give some examples to clarify what that means. We're going to focus today on the effects of this potential bias on basic rate estimation, our ability to identify clusters such as hotspots of mortality, elevated mortality, and also on statistical relationships with other environmental and social factors. We're able to talk about and study scale thanks to access to a novel database provided by the Colorado Department of Public Health and the Environment. It features individual demographic and cost-specific death information. It's on an annual basis since 1990, and it's georeferenced to the block level, census block level. We can combine this, integrate this with data on population and economic characteristics from the NHGIS to understand how sub-county scalar, how to analyze sub-county scalar effects and alternative regionalization strategies. So we can think about delineating space using census boundaries, for instance, counties featured in the top right panel, largely defined by population characteristics. And it's not a bad approach on the surface. But in this case, given the access to this very fine scale, high resolution data, we can also consider what if we delineated space based upon mortality characteristics. And you can see an example of how different that looks on the bottom right-hand corner. And so the way that we delineate space based upon mortality characteristics in this case is by creating a hierarchical network. And we borrow from network scientists that developed this method for studying traffic flow on social media, or between an email or other cases like this. And we adopt their methods to our own case. And here we're creating a weighted network of census blocks, neighboring blocks. And we defined the relationship between them, the weight of an edge, if you think about a network context, as the correlation between their cost-specific mortality rates. So that neighbors that have more in common in terms of cost-specific mortality are more likely to be grouped together into common communities. We use the Louvain method in this case, which is effective, has been shown to be effective for very large data sets, in our case, millions of edges connecting adjacent nodes, neighboring blocks. It optimizes intra-group connectivity, which is just another way to say correlated mortality in our case. It's a two-stage iterated algorithm. In stage one, it finds the local maxima of neighboring pairs, finding which blocks are most like each other. And then in stage two, evaluates the benefit of grouping those neighbors into communities, and then communities of communities, and so on until there's no more optimization available. And this results in a hierarchical network of neighbors nested within communities, nested within communities of communities, and so on, to naturally produce a scale, a multi-scalar way of organizing places, census blocks into communities, and so on, based upon their mortality trends. And you can see the visualization of what this looks like, the finest scale being in the top right, individual blocks, nested within communities, colored in the yellow shape, which is found now in the red shape, red outline shaped, and finally into the course's fifth level of aggregation in the Colorado map. In these two figures, you can kind of see what the difference is in age-adjusted mortality rates when we use different levels of aggregation and zonation. So on the left, you have the standard blocks, census blocks nested within census tracts, nested within counties. And you can see in a very abrupt way, a quick convergence upon some measure of central tendency. If you think about these density plots as being similar to topographic maps, but featuring the really delineated the density of points in this case. Tracks showing a little bit more dispersion in terms of area. I should say areas located along the x-axis, mortality rates along the y-axis. Some more dispersion than counties. On the right is the effect of our 5-level network-based mortality regionalization. A much more gradual convergence towards, in the violet, you see the coarsest level of aggregation, similar in terms of its central tendency to the census level. And beneath that, much more dispersion in terms of area and estimates in what would be the level 1 through 4 scales of aggregation. So I'll just say a couple points here is that at the coarser scales, whether it be the county level or the level 5 level of aggregation in our mortality regionalization, there are some benefits to this, including far less zero estimates. If you look at how much they're flattened along the x-axis, far less places with zero mortality in the data, and more convergence around some measure of central tendency, which means the data is more likely to satisfy the assumptions of classic regression, including having a normal distribution. That said, below that, at finer scales, whether it be the tract or levels 1 through 4, we're more likely to identify outliers that are important to us, including hotspots where there is higher mortality than in other places. And that's what I want to talk about now, are the results of our what's classically called a Lease Analysis, or analysis of local indicators of spatial autocorrelation. I'll probably use hotspots more often because I think the intuition is easier with that. What this is showing is the result of the Moran's eye statistic that's estimating how often elevated mortality in one place is located adjacent to more elevated mortality in other places, in neighboring places, right? So think about these as clusters. They're labeled as high, high. That means high mortality clustered next to high mortality in space. When we do that at the county level, when we conduct this analysis at the county level, we see hotspots of mortality, age-adjusted mortality, in the Great Plains part of the state, in the eastern part of the state, and the northeastern and southeastern parts of the state. This is consistent with what we might expect from the rural mortality penalty. When we move to the alternative regionalization strategy, this is now delineating space using our networked method. We see a similar pattern of hotspots in the northeast and southeastern part of the state. They're delineated differently, but they're in the similar regions. We also see, We also see very small spots in southwestern Denver that were not identified before, and a hotspot in the western part of the state, south of Grand Junction. So this is purely the difference. These are about the same scale as far as the space aggregated, purely a difference of an alternative regionalization strategy. We see new spots and some different delineation of space. When we move to a finer scale, so this is level 5, this is the coarsest level of our network approach. We move to a finer scale, we see that, and so the previous hotspots are still kind of bound in this red outline, but the new hotspots at level 4 at the finer scale are now in red, full in red. And so we see that really there's only a small section of these larger regions that are driving the hotspot identification, and that their distribution and magnitude within however we regionalize is really driving it. And I want to take another step further. So that's level 4. Let's go down all the way to our finest scale and look at the block level. So now we have the county hotspots, if you can see, still in the red outline, which are in the northeast and southeast part of the state. Very different distribution, much more clearly clustered around Denver and Boulder. There are some hotspots, but also following the main roadways throughout the state. And what this maps onto is the distribution of many of the places in Colorado. So one might infer from this the characteristic scale of age-adjusted mortality is probably the place level. It's well studied at the place level. But not all places are equal. Look, for instance, around Aspen in the central part of the state. There are a number of places that are not hotspots. So just because so there is important variation between places in terms of their mortality experience. And this is probably something we need to think about when we move into both studying the drivers, but also considering interventions. So what can we take away from this Lease analysis? One is that high mortality rate clusters, the high clusters or hotspots, tend to be in cities and towns, but there are notable exceptions. For instance, the towns around Aspen. That regional hotspots are located on the Great Plains and in Western Colorado. And they're really defined by the magnitude and distribution of the local places underlying them. coarse scales run the risk of missing hotspots in small, isolated communities, which is particularly relevant if we're concerned with rural mortality penalties. And just a note, on the right, I'm still showing the age-adjusted mortality rates by scale and regionalization strategy, but now I've overlaid in red the mean in the dashed line and the range in the red bar of place, of area, the size of places in the state. And so you see that tracts are probably a pretty good scale if we want to use the classic census administrative boundaries approach. Pretty good scale to study this dynamic, or either level 3 or 4 of our Louvain, of our networked approach. Okay, so now what I want to do is shift focus a little bit and talk about what are the effects of scale on our analysis of mortality, and specifically, what are the effects of the on the inference we can glean from regression modeling. So these models are all spatial regressions. There was important spatial clustering at all scales of analysis considered. So it was important that we consider the spatial nature of the data in the shape of the regression, and we're considering the log of mortality now. One thing you can see, now this is the first panel we're looking at is our hierarchical network based upon mortality rates, is that there are some factors, predictors, that appear to be scale independent. And I'm thinking about the share of the population that is living alone. You can see from the block level at the top all the way to the courses level 5 at the bottom that though the effect size varies, generally the significance does not vary, and it's consistent in the same direction. It is positively associated with higher age-adjusted mortality rates when there's more of the population that is living alone. I should take a second here and first orient you to the nature of, this is me sneaking a table into a presentation. So even though we're not supposed to have tables generally. So the darker the shade of the color, the more significant it is, capping out at below 0.01. Gray circles are insignificant statistically. Blue is negatively associated with age-adjusted mortality, which is to say, when that factor is higher, age-adjusted mortality tends to be lower. And the inverse is true with red. So we talked about living alone being scale independent in this approach to regionalization. For a large part, the share of the male population, the share of the Hispanic population has similar properties. If you look at the estimates, the effect sizes of the Hispanic share of the Hispanic population, it's remarkably stable. And I actually had to double check this morning because I thought maybe there was an error. These are consistent effect sizes across the scales of aggregation, and it's true, they hold up until the courses level of aggregation. Population density to some extent is similar, with the one exception that its effect size grows as you aggregate up until the courses level of aggregation. What's noteworthy is using the share of the Native American population, indigenous American population, as a predictor of age-adjusted mortality. It shows both a scale-dependent effect, but also a dynamic where the direction of the effect changes based upon the scale of aggregation. And I'll give some examples or some ideas about why these scalar properties are happening in a slide or two down the road. Now we're looking at the census approach to regionalization and the scalar effects therein. We see some similar trends, and I think I'll just jump on to the next one where we see them side by side, in the sense that the share of the male population and the share of the Hispanic population are consistent between blocks and tracts, but then are no longer detectable at the county scale. Population density is only detectable at the mid scales, whereas in this case, this approach to regionalization, the share of the population living alone is only seen as significant and positively associated with age-adjusted mortality at the finest scale at the block level, aggregating to the tract or county level, aggregating using their approach by population dynamics, population characteristics, does not detect this effect. And once again, we see a mid-level of aggregation finds a negative correlation between the share of the population that's Native American and age-adjusted mortality, but a positive at coarser scales. So I'm going to highlight a couple of these, and if we want to circle back during the Q&A, I'm happy to discuss other factors as well. Why these scalar dynamics may be seen in regression analysis. First off, living alone was regionalization dependent. I'll jump back here. It's scale independent using our mortality-based hierarchical network, but is not detectable at coarser scales using tracts or census or tracts or counties. It is the share of the population living alone tends to be concentrated spatially in towns and cities, especially in the eastern half of the state. And so this is why I think it's broadly distributed and fairly common. And so you see this across scales using the mortality approach. But probably what's happening in the tract and county data is that it's being aggregated with adjacent rural areas that dilutes the effect. A similar process is probably happening with the share of the population that is Hispanic. Recall that this is a predictor that is very stable in terms of its effect size and significance at finer scales, but then falls off, is no longer detectable at the coarsest scales. And I suspect this is a result of the highest Hispanic populations tending to live adjacent to places with high property values. And so at some level of aggregation, we're seeing very different populations being grouped together in terms of the average characteristics of the communities being studied. And then population density, to the extent that it's correlated with places throughout the state, is fairly well detected across the scales, but mostly at the middle scales. And I'll say that probably what's happening at the coarser scales is in both the case of our hierarchical network and in the case of counties, is that urban and rural places are being grouped together, and that dilutes some of the signal. Okay, so the last thing I want to kind of touch on is take a bit of an aside and talk now about urban and rural dynamics. So we mentioned that early on there's evidence that age-adjusted mortality in Colorado is really place-driven as far as scale goes. Well, if we use population density, which is spatially correlated with places in the state, as a predictor, it tends to be a fairly good predictor, as we showed in the last couple slides. But we can also learn from plotting the residuals, which you see in the map to the left here, and looking for regional trends. So these are the residuals plotted in space, which is to say, what does population density not explain? And it's interesting because we see some very noteworthy regional patterns. Especially in the eastern part of the state, up to the Front Range, has higher than expected mortality rates in general. And there are parts in the western part of the state that do as well. But there's also a band through the center and going out to the west where there is lower than expected mortality. And I'm just, the takeaway here is really that there are also probably some regional trends worth exploring, and they map on to a greater or lesser extent to how we might think about the physiographic regions of the state, which are shown in the right-hand part of it, or the right-hand figure. And so using this same idea of rural places being generally located on the Colorado Plateau and the mountains and the Great Plains, contrasted with the more urbanized Front Range communities, we can then look at trends amongst people of similar age born in different years living in these regions. And I'm just going to call out a couple examples here that are most noteworthy because they make for interesting discussion on the urban-rural dynamic. First, if we look just at the 60-year-old cohorts born in the 30s, 40s, and 50s, we see similar trends across regions, across both urban and rural regions. Rising rates of traumatic mortality over time amongst all regions, with the exception of the Great Plains, amongst, I should say, white males are on the top row, white females on the bottom row. White males in the Great Plains are not necessarily rising, but they do have the highest mean amongst all groups. And then if we look at, in a more encouraging note, cancer and blood-related disorders, those are falling across all regions. So these are shared trends across the state, across urban and rural areas. And I'll say that we're focusing on white males and females here because they're the most well-represented in the state, but we've looked at other racial groups as well. Now to talk more about differentiation. So if we look at circulatory disorders amongst 40-year-olds, we see that they are showing diverging trends based upon the region in general, rising in the western part of the state, high or rising in the Great Plains, but stable and relatively low in both the mountains, the rural mountainous parts, and the more urbanized Front Range. If we look at digestive disorders, we see something of a similar pattern, although are definitely rising in the urbanized parts of the state and rising or high in the more rural Colorado Plateau and Great Plains, parts of the state that we generally associate with being poorer on average or lower socioeconomic status. So the takeaway here is really just that there's evidence of converging trends amongst urban and rural places, but also important factors differentiating them. So some takeaways from our work to date. Scale and regionalization strategies both influence the study of mortality in multiple ways, both in terms of hotspot analysis, also in the regression estimates that we can produce, that we can generate. There are merits to this county scale of research. I mean, obviously, given the wealth of data of research that's been done to date, some of the merits are practical. The data is readily accessible. It's easier to satisfy traditional regression assumptions, such as the assumption of normality in the data, and it's directly linked to local governments, which can facilitate implementation. But there are risks associated with coarser scales of research as well. It's difficult to capture the place-to-place variability that appears to be underlying the overarching trends. And there are some scale-dependent predictors that, according to our data, at least in Colorado, are not identifiable at coarser levels. Also, from a theoretical position, the conceptual models that we talk about for mortality or health in general are an interaction between behavioral, individual, and socioeconomic drivers. This is implicitly a multiscalar process, and it most likely manifests at the place level. And you can see that featured once again by revisiting these spatial autocorrelation results, the hotspot analysis at the level 5 level on the right, on the left, the most regionalized model using our hierarchical network, contrasted with the block level on the right. Very different spatial patterns and very different ways to respond to this if you're thinking about health interventions. I'd like to thank the support I've gotten, both in terms of collaborators and student assistants, as well as the funding agencies and data providers. And with that, I will stop and open up for questions.
Cyrus, thank you very much. This has been really interesting. I don't see any hands up yet, but let me start with a question and ask you to put that last slide, not the last one with all the thank yous, but the one before that back up. You know, the last one that has, that one there. So you know, the interesting thing, you know, when I look at this is not only to see the importance of places, but the importance of what drives certain kinds of places. So you see Interstate 70, you see other highway and transportation routes on here. And do you think that that is a function of the kinds of population that are living in certain places? Is it a function of, you know, so what's driving those particular place-based things? So why do Aspen and Steamboat Springs have low? Why do the highways in from the east have high mortality? How do we disentangle that?
Well, we're already treading into speculation area, just as a caveat going in. One of the ways that researchers have thought about this rural mortality penalty, but really rising mortality rates in general in America, is a function more of social and economic processes, economic restructuring, and how some groups are disadvantaged by that. I think that what we may be seeing, since we're talking about fine scale geography, but coarse scale mortality causes, because we're talking about age-adjusted mortality writ large, as opposed to a specific causal factor. This may be the function of multiple causes rising as a product of a social burden produced by economic restructuring as one kind of big picture driver. That would be reflected in the economic nature of connected to infrastructure, for instance. That would be where I would start to look at this. But the second step I would take is to then disaggregate this and look at conduct similar analysis with major causes, right? So going back to the birth cohort analyses and thinking about how are circulatory disorders or certain metabolic disorders reflected in a similar analysis, as opposed to, say, nervous system disorders, which one would suspect both from our analyses, but also from some of the underlying causes, that might be more common in urban or denser areas, as opposed to, say, the classic deaths of despair, which we would expect to see higher in some rural places. So hopefully that gets at some of your question. The short answer is, I think the social burden of economic restructuring is part of what we may be seeing there.
Great. So we have a question from Chloe Wasserstrom now.
Yes, hi. My question is, what do you plan to do with your future research, and do you have any plans set already?
Some of the next steps as far as analytically, I talked about looking at specific causes, conducting similar analysis, but also thinking about how aggregating across years may affect the data as well. Sometimes, we've kind of started with grouping the data around the census dates when we know the population estimates are more reliable. But you may be able to get around some of the, let me say this better. You may be able to get some of the statistical benefits of coarser spatial scale aggregation by aggregating temporally. And we should investigate that as well, since we have the opportunity to do so.
And have you started this yet or no?
Not. We've done some of the causal specific analyses, but not using all the methods that we've developed on the age-adjusted mortality.
Okay, thank you.
Great, Jason. Jason Boardman. Jason.
To me?
Yeah, you.
Sorry. It said just Morgan. I thought, I appreciate that. So, Cyrus, this was great. And one thing I want to ask you, and this is because of work that we recently had published in a completely different, but actually somewhat related question, and that is rural-urban health disparities related to, in our case, genotype. So we took polygenic scores that are identified with common morbidities and health well-being, compared the associations of those scores with their corresponding health outcome among rural and urban respondents, and basically found very, very, very weak, basically non-existent associations among rural residents, but strong, as you'd expect, predicted associations among urban. And it really started getting me to think about the composition of who was selecting in. And so you can imagine if there's a selection of a certain type of person into a rural area as a function that's linked with their genotype, guess what? You reduce the variation in genotype, and associations get muted for selection purposes or because of environment. But that's a long-winded story of saying, how much do you think your story here, especially in Colorado, and changes over time, is a very different composition of rural residents over time in terms of being selected from the population? What's your sense on that? I didn't see that as a big part of your presentation today.
Changing composition of the rural residents. That's the, yeah. I would be amazed if that wasn't a factor. I mean, given how the mountains stand out from the other parts of the state, and this is true in just about every way we've looked at it. There's a you've got to imagine both a physical and a socioeconomic selection. Not seeing hotspots around Aspen, I think, is telling. So I think that's part of it. So that I'll just confess to that.
So if from all their sending relocation areas, are they being drawn from not just a particular part of the SES distribution, but of their local health distribution, are the most healthy, regardless of SES, selecting into rural areas right now, like something we've never seen before? And can we anticipate something that looks very different in the next decade, 2 decades?
Are the healthiest selecting into rural areas? Yeah, I mean, I don't think we can study that even with this fine scale data. We can't study that. I don't imagine, but I think they're selecting into some rural areas, right? The best rural areas, if we might think about it as far as amenities go, is what I would expect. But selecting out of, if we go back to the economic restructuring driver, selecting out of other places would be my expectation. But I can't speak to that with confidence with our current data.
Thank you.
Janie can figure it out.
Jane, you're next.
Thank you. Cyrus, this was fascinating. And my question has to do with the big red up in the Northeast that became small clusters when you went to smaller units. And say Denver, highly densely populated, where you saw a differentiation that you couldn't see before when you were dealing with the larger aggregation. For the smaller areas, could it be that those are the only places people are? So that when you disaggregated the big red in the Northeast, you're just going to the places where there is some population. So that I don't yet know how to think about this. That disaggregation allowed you to see something different in Denver, and disaggregation may not have done anything except locate the population spots in the sparsely populated areas. What do you think?
Well, it definitely located the population spots in more isolated areas, less densely populated. We've done this multiple different ways, so I don't think that, early on we were concerned that just may be a boundary effect rather than anything else, and it's consistently showing up with this pattern. So I don't think it's an artifact of that. I think when we find hotspots in rural areas, it's implicitly going to be driven by a few places, and they're just being, they're weighted more than the surrounding areas. I'm not answering this very well. Let me think. Let me take a moment to think a little bit more.
Well, I just wonder if there's really differentiation amongst the population spots in those sparsely populated areas.
It's hard to say. I mean, we find differentiation between places in the mountains versus, say, the Great Plains. But I would kind of expect, if there's this rural mortality, that many of the places in places that are undergoing economic restructuring would share a similar pattern because they're sharing similar pressures. I don't know if that really gets at your question, but
let me try and phrase it better.
Okay.
When you look at the big red, where are the people? Can you, if there are no people outside of the hot spots, then the interpretation is that whole area is a hot spot. If there are lots of people outside of the hot spots that are in areas that are not hot spots, it's showing variation within the red. and I can't tell
Right.
from, whereas for the Denver, it was very clear
Yeah.
that when you aggregated, you did not see what was going on in the underlying pattern.
And I think part of what I'm struggling with is the focus on the northeastern part of the state. But let me cheat and say, if we look at a different part of the state that is not as densely populated as Denver, if we look at the mountains, we definitely see differentiation between places. That is, it's almost certainly driven by population characteristics, but not population size or density, I expect. So, so no, I don't think it's just the distribution of where people are living, because I think the mountains give a better sense of how it's differentiated, rather than us identifying just where people are living, which on the eastern part of the state, it tends to look a lot like that.
Okay.
Jeannie.
Thanks, Cyrus. That was so fascinating. And the overwhelming question is, why have I not met you before? So I am really attracted to your work. I have a million questions. I'm trying to decide what to ask. I think the data set that you're using is terrifically unique. And I didn't know that it existed because with my work in restricted data, then usually the vital stats are limited to the county level, and that's why I'll use that. In fact, we think about even going higher to like health service administrative units, because those are kind of aggregations of counties that have common demographics. But so I'm wondering, was this a special contract that you arranged with the Vital Stats Department at Colorado Department of Public Health?
Well, I have to confess that Stefan did most of the hard lifting on that part of it, so I can't say. I mean, there's definitely a data sharing agreement
Okay.
underlying it, but you'd have to
I
follow.
didn't realize that they gave it out at lower levels of geography, which I'm really happy to hear. So I'll bother the Vital Stats people about that.
Yeah.
Jeannie, let me add that we've discovered that this kind of data access is not impossible in a variety of states. So we already have access to, we're on our way to getting access to Oregon, and we've discovered a number of other states that have a facility for delivering at least block scale, not track scale data. Stefan might say more as well.
That's wonderful. But my question about the data is, you know, in Colorado, we have a lot of tourists and students and people who come here and explore high-risk areas. And so do the data allow you to distinguish between people who are dying in these blocks or living in these blocks? And maybe you don't know the answer.
Well, I don't believe they allow for us to distinguish. My understanding is that these data are for residents of Colorado, and so visitors would probably not be featured in the data, or they, even if they are, they're almost certainly not geo-referenced. And so I don't think that that's a population that's included in our analysis.
Okay, I'm not sure of that, because the death certificates are registered in the counties and states where they died.
Oh, okay.
Anyway, subtle point. There's so much to digest, and this has to do with Chloe's question. Do you have some working papers or anything that you could share with people like me who want to look at things a little bit more in the specifics?
Not yet, but we'll be happy to share it when they're ready. Yeah.
Okay, thank you so much. Really
Thank
appreciate
you.
Yeah, Scott.
Thanks, Cyrus. This is super interesting to me. This is a question just coming from a place of ignorance about the census. So in thinking about what the properties, I mean, since you begin with census tracts and then aggregate them in different ways, it seems like variation in what a census tract is across space might have an impact on your results. So what I'm asking is is a census tract like roughly comparable numbers of people across the variable areas over, sizes you have to go to get to them, or is it a common size and whoever happens to be there and so on? What can you tell me about that?
Well, we're working with the finest scale we have is the census block, which is smaller than the tract. And they do vary with population density or population size. So there is an artifact in both counties and in our networked hierarchical network approach, where you'll see rural areas are larger, and part of that is because the underlying units of analysis are larger. There's not a way to get away from that because of the nature of the blocks.
So I mean, what I'm thinking about is, so if your analysis, if two tracks need to be adjacent to each other for them to potentially be aggregated, then the larger the spatial dimension of the tract, the more likelihood they're going to be able to be connected just because, right? And so I wonder whether, what I'm wondering about is whether there's something about the character of those tracks that sort of imparts an intrinsic bias in favor of higher mortality rates in rural areas that is sort of almost in a way a little bit misleading. And I'm just thinking more about how striking it is that somehow Denver lights up, like a forest fire when you do your approach with the data, but yet when you do it at the aggregate county level, it's like not there at all. So.
Well, it is there, depending on how we regionalize. So it's not there when we do it at the county level. When we use counties, we don't find hotspots in the Denver area. When we do the aggregation based upon the correlated mortality, we do see hotspots in Southwest Denver that only become more exaggerated as we move to finer and finer scales. But it's only a part of Denver, right? So it's a distinct section, and I don't see that level. I don't see that happening at other denser parts of either Denver or other urbanized parts of the state. So, but I mean, certainly the risk of boundary effects remains and can be a problem. I think the underlying spatial bias implied by the different size of blocks in urban areas versus rural areas remains, but I'm not sure that that's driving the data. We've looked at it a couple different ways, including using different proximity measures to aggregate rather than just an adjacency metric, and the results are fairly consistent. So,
like using the centroids of the census tract or something.
Yeah. These results are definitely based on the centroid, although you would still expect those to be further away in rural areas than urban areas. But, yeah.
Right. Okay. Thank you. Yeah. Interesting.
Amanda Stevenson.
Thank you for this. This was such an interesting piece of work to hear about, and I'm very excited. I have like a million questions, but one of them is this question of migration. And in particular, in our work in Colorado, in a completely different world, we found that a lot of Coloradans aren't from here, unsurprisingly. And the people who moved to Colorado are really different from people who already lived here. And this is especially true at the cohorts that you're that you showed specific results for, but also the people who are starting now to die. So I was wondering, I get that I don't understand exactly what kind of data you have, but I was wondering if you've thought about that with these data yet. And I thought I'd suggest that the census has, the SSA data, and they have where people were born, and they've got a lot of information about where people live. And if you ever get into this business of wanting to know, like to track people over time, we've actually developed ways to link that to people's spatial location across time for the entire United States. So thank you so much for this. And I would love to know more about like how you're thinking about migration and its potential influence. Thank you again.
That's a great question. I think last word to Chloe.
Yes, I may have missed this, but how long have you been working on this study?
I think about a year. Does that sound right, Myron? We've got a lot of irons in the fire. I can't remember when we put this one in versus some of the other ones.
Summer 2020, so about 15 months.
And what made you want to begin this study, or it inspired you, or how you got here?
So this arose out of a larger project that Lori Hunter, who's not with us today, initiated to study the characteristics of small towns in the United States. And we've asked a whole lot of questions in a broader research program about what makes little places different and how does the scale of analysis between the place and larger entities like counties matter. And this is what, repeatedly the questions have been. And so one of the topics that came up in that line of research was to understand what we would learn by studying mortality records at very fine spatial scales. And Stefan was able to work with the Colorado Department of Public Health and Environment to get access to these data. So that it's a way of thinking about spatial scale as it applies to a lot of things that we've been doing. And Lori led the project to get a grant initially from the National Institutes of Health to support the broader research agenda. And then over the last year, we got seed money for more research from our own University of Colorado Population Center, and from which is funded by the National Institute of the Eunice Shriver National Institute of Child Health and Human Development. And then we got additional funding from a network that's organized out of Penn State that supports studies of rural aging. So we had this long-term project. This was an interesting set of questions. And then we were able to leverage that into some additional funding to study this specific problem.
Great, thank you. Byron, can I just ask you like 3 questions after the presentation's done?
You want to ask me?
Yeah, just for this article, if I could just ask you a couple questions.
Or yeah, I mean, Cindy, can you make sure that we can stay on? Thank you.
Thank you.
Welcome.
So Fernando, any last words?
Well, on that note, simply to say, related to the larger project, that then our next talk will be on October 18th by Dylan Connor, who is going to talk about the changing populations and economic fortunes of small places in the United States. So related, I guess the talks were sort of clustered depending on the scale you look at.
Yeah, that's another part of our project.
All right. Thanks, everybody.
Great. Okay.
I think so.
And thanks, Cyrus, especially, of course.
Yeah. Okay. Yeah, Chloe, I'll stay on.
Thank you, thank you.
Thank you. Thanks, Myra.